Outliers, as the name suggests, is something that is significantly different from the normal behavior. There could be multiple reasons for outliers to appear in your dataset. It may be possible that someone has entered some extreme values while making a data entry or while measuring any attribute. Outliers can also be a result of your data processing logic. Many a times, by nature, some values can be extreme. But the question is, why should you bother about outliers? Well, if you are performing some kind of analysis on data with outliers, then it may be possible that your analysis become biased due to the extreme values. We have already seen how mean, range, variance, and standard deviation can be impacted by extreme values. And moreover, if you're creating predictive models, then outliers can impact your model and model outputs. So in summary, outliers can be problematic for you. But how do you detect outliers after all? Well, there are methods of outlier detection ranging from very simple ones to very complicated and sophisticated algorithms. Let's look at very commonly used visual tools to detect outliers. So if you are working on only one variable, then you can use histogram to have a general sense of data distribution and use it to detect if you have extreme values in your data. Here you can see a couple of bars are far from the most of the crowd, so you may have some outliers here. Other than histogram, you can also use box plot for univariate outlier detection. We have already discussed that you may find dots beyond the whiskers that represent outliers. So the points beyond 1.5 times the interquartile range will be treated as outliers as per the box plot. You might want to refer the box plot discussion in the previous module in case you have missed that. Scatter plot is another very useful visual tool to detect outliers, especially for a bivariate distribution. Here you can see the 2 points are outside the typical crowd of points near the origin. So overall, these visual tools can be very handy for outlier detection. You can also read about more sophisticated outlier detection algorithms, but it is beyond the scope of this course. Well, you know how to detect outliers. The next question is how to resolve the outliers issues. Well, as the simplest solution, you can simply remove observations containing extreme values. But if you are throwing away data, then obviously you are removing some important information. Sometimes you can apply transformation on features to treat outliers. For example, you can take a log of a feature or take a square root to reduce the impact of outliers on your analysis. Binning is another very useful technique to treat outliers. So in binning, you create bins and then you put your values in the bins. And maybe you can put your extreme values in a separate bin. Imputation is also used to treat outliers. And just like the missing values, you can impute or replace extreme values with more reasonable values. Sometimes it can also happen that you may not want to treat the outliers, but then also you should definitely explore them. Outliers often carry some very interesting information that can be of great help. So now we have made some ground about outliers. Let's see if we have some outliers in the Titanic data.